Alright, let's look at the compositions of functions. Alright, so notation is f circle g, so f of g, which means that we plug g of x into a f function. So this is just going to be f of g of x. Alright, the interesting about this composition is that finding the domain. So in order to determine the domain of the composition, we have to make sure that x is in the domain of the inside function. In this case, inside function is g, the second function. And then also, since we plug in g of x into f, we have to make sure that g of x is in the domain of f. Right? So let's dive right into a couple of examples. Right? So let's try to find, let's say f of x is x squared, and g of x is square root of x. And domain of f is all real numbers, and the domain of g is all non-negative real numbers. Alright, then let's find the f of g. So f of g of x, which is equal to f of g of x. Alright, so we work inside out. So we plug in g of x, which is, so we're going to put f of, right, inside function is square root of x. Alright, then we have, right, we plug this into this, so it's a square root of x, then you square that. Right, then this is going to be equal to x. Right, so this is the f of g. What about the domain of this guy? So domain of f, f of g. Right, first we have to make sure that the g makes sense. So we know that the x has to be in, so x has to be in the domain of the inside function, which means that the x is greater than or equal to 0. Right? Then we also have to make sure that, so I'm going to put 1 and 2. And we have to make sure that square root of x, which is an inside function, has to be in the domain of the outside function, but the domain of the outside function is all real numbers, so it could be anything. So only condition we get is the x is greater than 0. So therefore we have domain of f of g is simply non-negative real numbers. Alright, how about g of f? So let's find the g of f of x. Alright, so this is going to be equal to, right, g of f of x. So f of x is x squared, so it's going to be g of x squared. Right, and we plug it into a square root of x, so it's a square root of x squared. Alright, so this is going to be, since x is squared, a negative sign, everything is going to be non-negative. So even though the square root and the square cancel out, it's not going to be just x. It's going to be an absolute value of x. Alright, then here we have to check the first condition to find the domain. So we have to be inside, x has to be in the domain of x, but the domain of x is in all real numbers. So it doesn't really give us any restriction. And 2. And we have to make sure that inside function, in this case f of x, x squared, has to be in the domain of g, which is from 0 to infinity. So it's already there because x squared is never negative. So there's no restriction. So domain, therefore, the domain of g of f is actually all real numbers. All right, so that's that. All right, let's look at the second example. Let's say f of x is x plus 1 over x, and g of x is x plus 1 over x plus 2. All right, and the domain of f of x is obviously there's x on the bottom. X cannot be equal to 0. And for the same reason, for the domain of g, x cannot be negative 2. All right, so let's find the g of f. All right, so you have g of f of x. And in this case, f of x is x plus 1 over x. All right, so we plug this guy into a g function, so you end up getting, so you see x, you have x plus 1 over x, and then you have plus 1. All right, and you have another x on the bottom, so instead we put the x plus 1 over x, then you have plus 2. All right, and if you want, you can multiply top and bottom, since I don't like to have fractions inside fraction. So I'm going to multiply top and bottom by x to get the expression x squared plus 1. I'm going to put it at the end, and plus x over x squared and plus 1 plus 2x. All right, actually the bottom one can be factored out, so we can also write it as x plus 1 squared. Then on top, I don't think we can do much, so I'm gonna just write that down. All right, so this is the g of f there. All right, how about the domain of g of f? All right, so first condition is we have to make sure that x is in domain of inside function, in this case f, so which means that all real numbers except for 0. So we have to eliminate 0, so it's a negative infinity to 0, skip 0 to positive infinity. All right, so that's that. And the second condition is that inside function, which is f of x, so f of x is x plus 1 over x, we have to make sure that this guy is in the domain of g, which is all real numbers except for negative 2. So maybe I'll do it this way. So we don't want this guy to be negative 2. All right? And which means what? So I'm going to solve this inequality, multiply by x. So we have x squared plus 1 cannot be equal to negative 2x. All right, then I'm going to add 2x to both sides. So you have x squared plus 2x plus 1 cannot be equal to 0. And we can factor this guy out. So x plus 1 squared cannot be equal to 0, which means that x cannot be equal to negative 1. All right, so which means that we have to eliminate 0, right? And also we have to eliminate negative 1. All right, so therefore the domain of the composition g of f would be, so therefore domain of g of f is equal to, right? So all real numbers, so we have to skip negative 1 and we have to skip 0. So we have negative infinity to negative 1, skip negative 1 and skip 0 and go all the way to positive infinity, right? So this is the domain of a composition g of f. All right, that's it. I hope that this was clear.